Welcome to our second installment of Fair Data Principles and Practices, titled Fair Data in the Real World. And so our idea was to sort of scaffold on the last workshop that we gave about sort of the underlying fundamental principles of fair data, to sort of give everyone practice in sort of evaluating data for fairness, looking at how to prepare data to be deposited in a repository, how to consider our own sort of data requirements in order to make sure that we are publishing and presenting fair data in the real world. So welcome. Just a quick round of introductions of your presenters. My name is John Watts. I'm the Director of Research Data Management Services at the A&M Libraries. We like to give a little data confession as well. So one of my personal deep goals in life is to get everyone to use the global standard for calendar dates, which is year, month, day, rather than what we typically do in the US, which is month, day, year, which causes a lot of confusion and disorganization in our file structures. So I'll move it on to Dr. Tabor.
Hi, everyone. My name's Daniel Tabor. I'm a third-year assistant professor in the Department of Chemistry. And my data confession, we made this slide deck this slide in particular made a couple weeks ago. So until this most recent year, I used to do my fantasy baseball draft in a very hacky way, but now I can actually change it and say that I wrote a Python script that is idempotent. So we all do improve over time, but it was bad for about 6 years. And enjoy opening day tomorrow.
Awesome. All right, Laura.
Howdy, everyone. My name is Laura Sare, and I'm the Government Information and Data Librarian. And I am a birder, and I collect data on birds, including sightings by county, as well as recording audio songs.
I'm just gonna, as people are sort of filling in the chat with their information, I'm just gonna review kind of what we're gonna do, our roadmap for today. So hopefully our outcomes will be that you'll be able to choose appropriate fair solutions in biomedical research. You'll be able to appraise data using FAIR principles and evaluate data repositories based on the principles of FAIR data. So, so we'll look at some FAIR solutions. We'll look at some data sets and appraise them. And then we'll also decide what repositories would be good to use when we'd like to share our data and make it fair. So I see that we have some more folks from microbiology, fantastic. I see some familiar names as well from our previous session, so that's great. And I see someone from AgriLife, great. Modeling ecology, very cool. All right, we've got some diverse disciplines here, so that's fantastic. A little bit more about kind of how we'll communicate and work today. You'll engage in 3 different breakout sessions. So we have a pretty small group, so we'll have to decide kind of how we want to break everyone up, but we'll actually be using the breakout feature so you can have actual practice. I'm going to do a very brief review of what we sort of discussed in our last session. If you didn't attend that session, no problem. You'll be able to catch up, hopefully. But if you have questions, let us know. We'll use a Google Doc to share in those breakouts. So for each breakout here with breakout 1, 2, 3 are our directions. And we have about 3 groups, but we may not need 3. We may just need 2 or 1. But you'll have different prompts within each breakout room on this Google Doc, and your group, whatever number room you're assigned, will answer the question for that particular group in the document. So that's how that will work. So just be ready to either chat with people in those breakouts, unmute if you can, even share your video. Even better, I'd say that's the best. But either way, just be ready to communicate with each other and us. So You can ask us questions throughout. Feel free to address us individually or as a group of your presenters here. We're a small group, so feel free to unmute or just ask questions in chat. And if we ask questions, just please type a response. Sometimes the pause of the chat and the empty chat when we ask questions is a little death-defying. So we try to just say, if you don't have a response, just say no response this time, or no, or yes. So we'll have a lot of yes/no questions throughout too. So just keep that in mind as we move through our content today. So I think that is about it as far as we have for housekeeping and introductions. So I'm just going to dive right into a review of FAIR data. So what are FAIR data? And just give a little bit of a primer there and set us up for our activities today. So just a review to say that no matter what research you do or where you are in your career, these principles are applicable to you. The original FAIR standards or data principles are found easily online. You can just Google FAIR data principles, but the goal of this workshop is really to sort of get you a hands-on approach to learning about FAIR data and how to make your data fair. So you can kind of see, I'll share a link to the principles now. So here is the website. So you can kind of see it's very dry. They read a little bit like, I don't know, furniture assembly instructions. So we're trying to show what this means like in the real world. So what does this actually apply to in my research life? FAIR is an acronym for the principles indicating that data should be findable, accessible, interoperable, and reusable. And these principles are really interrelated, and there are many dependencies. So they really can't be reusable unless they're findable, right? So that I think we'll break these down just a little bit here to explain further. Really, FAIR data principles encourage the researcher and other stakeholders to ensure that research data are findable so that others can discover your data, accessible so that your data is available to others, interoperable so that your data are integrated with each other or used by machines, and reusable so that your data can be used for new research, so it can be built upon. And I just I'm one of those people who always wonders about what the room was like when people put all this together. So if this helps you understand, it was the FAIR principles really began as this workshop organized by a molecular biologist in the Netherlands in 2014. And it's from that workshop the kind of core principles were developed, but they've been revised by different research communities to become kind of this global force for best practice in data management, essentially. And the principles were drafted by researchers, funders, publishers, and university administrators who really wanted to find a way to improve the reuse of scientific data. So that's the end goal, is the R in FAIR. And each representative really expressed their own individual interests in this. So it truly was a collaborative effort. Researchers really just wanted better research output, something to improve their scholarly impact. And funders really wanted high research integrity. Publishers wanted to improve the research process, and university administrators just wanted to add more value to publicly funded research so that they would get more publicly funded research and just have a greater impact overall and a reputation for the university. So I think the shared goal here is really just a more rigorous management and stewardship of data to benefit the academic community as a whole. And really the ethos of these principles is that good data management is not just like a goal that we really want to like learn to have good data management practices, but rather it's sort of like this precondition, like it should be a given to have these practices and principles embedded in our research workflows in order to support knowledge discovery and innovation in our fields. Really is just a fundamental, these are fundamental principles and practices that we can embed throughout. So diving even deeper into this acronym a little bit further here, we'll just define each a little bit more. So defining fair data, making it findable, really what that means is that the data set that you're sharing should be assigned a globally unique persistent identifier, or a DOI, something that's resolvable permanently, persistently. So you kind of need to provide some details also for your data, known as metadata or data about your data, in order to make that data findable and also understandable and reusable. This is an example of a metadata record or just a repository site where some researcher has deposited data. You can see that they've been given a DOI, a digital object identifier, and they have some author information here. So that's their metadata about that particular data set. And I'll also say that making it findable with the rich metadata about the data set, known as metadata. So in addition, not just having author information, but diving a little bit more deeply into what is, what is the contact information for that particular researcher? What's the description of the data? What keywords are associated with the data? Who actually deposited it? What date is that deposited? And it can go far beyond this particular metadata record. The repository providing access to your data set should also, if it's accessible, should make the metadata describing your data set available. We should be able to download that, and your data should be downloadable. So you should be able to be accessed via a network URL whenever possible. So that is part of the accessible piece of FAIR. Interoperable means that your data can be integrated with other data. In order to make this possible, you need to really ensure that you're using standard vocabularies for your variables, for your methods, be understood and referenced by others, ensuring that all variables, any kind of language is named appropriately. So biomedical sciences really loves an ontology. I know this for sure, and excellent at documenting these ontologies. So this is an example of a database of ontologies that are used in biomedical sciences. So making sure that every element of your data is named appropriately. Interoperable also means that the format in which you encapsulate your data, so basically your files, can be opened and transferred without significant labor. So using open formats such as text files and CSVs preferred over sort of proprietary formats like Word documents or Excel files. This is to say that there's often a way to transform these documents once somebody downloads them from your repository, but kind of giving them automatically in an open format is preferred. I think there's more about interoperable than just the file format, and using preferred language should be readable by a human being, but also machine readable. I think the machine readable, if you need a definition, is just data in a format that can be easily processed by a computer without human intervention, and ensuring that there's no semantic meaning lost in that transfer. So I would say also the machine readable test, like the very basic way to test it is it any kind of structured data that you can copy and paste, basically, or can it be accessed using a network URL? And so move on to reusable. Information about a collection or generation of data should be included with your data. So data are really powerful and valuable when reused and built upon in research, but the unfortunate thing, unlike a published paper, is that data just really needs so much context for it to make sense. So data really needs to be well documented and clarified, really including kind of a list of things here on this slide that you could include. This basically the who, what, when, where, and why of your data. So, so that means that that's reusable, and this can really take form in many different ways. The way you document your data, that should be accompanied by some type of file any of these forms. And file names should be understandable. It can include just a text file or README text file that describes the methods, the software used, the type of data. Code books for your variables, so what codes are you using, and if you're using any kind of code or any sort of binary files, using Markdown within those files to describe your methods within the code is preferred. And last but not least, is licensing. So telling people how you want them to use your data. So first, I think also understanding how if you have data that you're using from someone else, secondary data, if you can use it and publish it, but also letting other people know when you publish your data or share it, how they should cite you and give you credit. So we have some examples here of Creative Commons licensing. It's become a fairly I would say regular approach to licensing data and publications in open access formats. So you have Creative Commons, you have CC BY, which asks that you give credit where credit is due. You also have the option of saying non-commercial CC BY and CND. So you can use it, give me credit, and don't use it for commercial purposes. Basically, don't make money off of it. So those are sort of the big three options that you can have. We also talked a little bit in our last session about research workflows that enable FAIR. So I just wanted to make sure that we covered that as, including that rich metadata and documentation throughout your research process, starting from the very beginning, trying at all stages whenever possible to use open file formats. Make sure that in the end your data are available in a repository assigned to DOI, and understand those restrictions and requirements for your data. So if you're working with proprietary data, if you're working with any kind of sensitive data with human subjects, then you know what you can and can't share, and making sure that you're licensing. So this is really just kind of the summary of what we just discussed, but these are all things that can be decided upon and enabled throughout the research process. So a lot of it kind of looks like this is what I do when the project is near the end and we're ready to share the data because we've already published the paper or we're about to. But really, it's a lot of planning in your data management plan that goes into this. So are there any questions so far about FAIR principles in practice, in theory? All right, thanks, Heidi. Anyone else formulating an idea? Right. So we have that information, we have that brief review. I know it's a lot to digest, even if you were in our previous session, but we kind of I think the best way to do this is to just kind of dive in and get some kind of a process of working through a scenario. So we actually have a few case studies that we'll go through, or research scenarios in breakout sessions right now. And really the purpose of this is just to apply FAIR principles to this scenario. So think about the scenario and answer some questions in this breakout document. Let me share that breakout document with you right now. So you should be able to open this and edit it. Okay, I see people joining in. Good. So, so in the breakout, you will you'll have a chance to decide for someone in the group to kind of take notes, which is just to answer these questions below, whether you're in group 1, 2, or 3. As a group, you'll read through this scenario, which is just a couple of sentences in the scenario. You can use this FAIR checklist that we used in the previous session to give you kind of a little bit of more context or reminders about what are the FAIR principles as you go through your scenario. So feel free to use that. So you'll just go through and answer these questions as a group. Every group has 2 questions. And I can give you about 15 minutes to do this in your breakouts, once you're in your breakouts. And then we'll come back and you'll share out to the main room, you know, what your take was on this.
So I'd love for, I mean, you all did a wonderful job, fantastic. We was just kind of looking at this as you were answering these questions. But I think it would be great to hear from you what your thoughts were. If you want to just sort of give a summary of your discussion, maybe just a brief summary of the prompt, and then your answers to the question. If you have one person that you could be your spokesperson.
Sure, I can start. I'm sorry if it's a little loud.
That's great. We can hear you.
Okay. So I guess just to approach the first question, when we were discussing and talking about points to make the data as fair as possible, the first thing that came to mind was ensuring that it's de-identified from actual individuals to make sure that you can make the data accessible in the first place. And then that would be including removing any sensitive health information or anything that wasn't relevant to understanding the results you were trying to convey to whatever repository you were seeking to submit it in. And that ensuring that any health specific lingo has been removed to kind of make it more understandable for a broader audience. And then after that, we kind of discussed about after you remove the identifiers to make sure that anything that was relevant to the study that the people who maintain the data set can refer back to the individual patient. So a way that doesn't completely randomize the data set. And then ensuring that data set was assigned with its identifier.
Wonderful. Anything else about what you would want to, do you have any kind of highlights from what would you need to help others reuse the data?
Yeah, I mean, for
you can go
reusing the data, just one of the big things was making sure that there's some sort of documentation that is assigned with its purpose, and that there's an identifier that continues on with this data set so that it can be used in the way that it was meant to be used for the study, and the data can be interpreted in a similar way.
Fantastic. Yeah, I think you've hit it on the head. I think the only thing I would say about this is the ensuring that data has clinical or health specific lingo removed. I think you would be able to include clinical and specific and health specific terminology for your data set in your documentation in the actual data set, as long as you're using that standard in your field. So I know that everybody has its own sort of departments and labs, and everyone has their own sort of culture and way they name things, but making sure that it is standard and not the lingo of that particular group or individual is perfect. So Probably the only thing, but otherwise fantastic. Group 2.
Okay, so can you hear me?
Yes, we can hear you.
Okay, great. So basically, we had a nice discussion. There were only two of us there. So basically, the question was, what is wrong? Like, what is the could be the problem? And then the second question was, what could be, the answer to this problem or the solution? So we both of us have some experience with this kind of like a similar, let's say, situation where same methods, but something doesn't work, something doesn't add up. So in my case, it was the different programs. So the software issue, the usage of, and even with the programs themselves, the settings sometimes might influence the outcome of the result. And then the choice of random number, that some software, some processing, or some algorithms use a random number. And if you choose a different one, then, well, you get randomness. Again, different just methods, starting from procedures or different statistics chosen, anything like that. And then the different baselines. So when you have different results, it depends on to which you compare. Well, of course, from study to study, it depends on the study itself, but choose the same baseline. And again, how to avoid all this? Well, first of all, the data was received from Google Drive, but was it retrieved the same way, first of all? And then was it retrieved at the same date? So check the metadata. So was the date stamp the same, or did you use the same method? And then again, standardized vocabulary, make sure that you use the same units, same attributes, that again, the same, did you use the same methods, and so on. Just go through the checklist, and then something might pop up and the team will find where they had an issue.
Excellent. Yeah, I think that you've really also hit this on the head completely. I think there's, I think one thing that's really nice about these two examples, these two different scenarios, is one of them is kind of at the end of a research project, right? And how FAIR really is enabled at that stage of research. But really, when group 2 is illustrated so beautifully here, is that FAIR data practices and principles can really save a lot of time and heartache in a research project from the very beginning if you are standardizing and documenting things very well. So using this sort of definitely documenting things like your retrieval processes, your vocabulary, your methodology, software versions, all of those things included with the data, and having a very extensive log would be something to alleviate those issues. So perfect. Wonderful. And thank you all so much for sharing out and all the great work you did in this particular breakout session. So this was really just to kind of get us kind of prime the pump for more work and discussion in how fair principles as they apply to different contexts. So we got kind of a little bit of a review here and a little bit of practice. And now we're going to move on to our next area here, which is just looking at an actual data set, evaluating data for FAIR. And I'll hand it over to Dr. Tabor.
Hi, everyone. Yeah, so as we move into sort of our next activity, instead of having like a 1-paragraph summary of the case study, we're going to actually deal with a real data set that's out there, and sort of go through a modified checklist to see how you feel about how well this data set is aligning from FAIR principles. And so what's shown on the slide deck right now is actually a piece of a table that was published, I believe it was mid last year in Nature Chemistry, It was actually a joint news and views / perspective, more front matter is the idea, by a bunch of researchers that work in machine learning for chemistry. And they sort of all came together and published actually a two-part checklist. One was solely focused on the data, because data is critical for training many of the kinds of machine learning models that are currently propagating through all fields of science, but in particular chemistry. And so what you can see here is they sort of classified this checklist into sort of exactly the kinds of workflows that they probably operate with a lot of the time. So sourcing, data cleaning or curation. Often many projects spend a lot of time on data curation. Chemistry and biology and medical sciences all deal with a representation sort of issue. And so, this is something that has to be enumerated pretty clearly. You can see some of the other ideas that are on here we've already discussed a little bit, including proprietary file types. This directly connects to interoperability. And then I would say that, the fifth item here, code and reproducibility, this also, connects both to interoperability, but also reproducibility and reusability is the idea here. And if you go, we'll link you to this paper as well. But the second batch is on actually these principles being then translated to when people publish the final models that are being used on these data sets. Okay, so if you look at the Google Doc, you should see a link to a folder on Google Drive, and then you also see a copy of the modified checklist that we have there. You'll find other checklists like this published in respective specialty journals and publications as well. They mostly have the same ideas behind them, sometimes catered a little bit to the particular field, but I think that this one will work well for this activity. In this case, you actually both have the same data set. So we're going to send you off into two groups and get ideas, sort of see, what the intersection of what everybody finds, and, also see what differences y'all notice throughout this data set. I think that's everything. Yeah, you have the exact same pair of questions. So it'll be interesting to compare and contrast what y'all find. Of course, you can scroll up or down, I suppose, while it's going on, but maybe, resist the temptation, I would say.
All right. Unless there are any questions, feel free to.
Yeah, are there any questions? Sorry, I should have prompted for the yes or no.
I didn't see anything yet. Questions? If we're ready to go, yeah, feel free to, I think you have your, how do we access the data? So just go to the link here. I'll also put this in our chat as well here. So this is the breakout 2 folder. This is where you'll get the data. And you can also click this link here, and then that will take you to this. So this is the author supplied metadata. This documents just how they've described the data. And then these are the actual files. So you'll look through this. Feel free to open those and preview, download them. You can do anything you want to review the data. You bet. All right. So we're going to take about 25 minutes for this one. So plenty of time to work in your group, and we'll see you in a little bit.
All right. I think everybody's back. Oh, so as you might expect, there was lots of overlap between what the groups were finding, but I do think that it would be good for us to hear at least a little bit from each group. So let's start this time with group 2, out of sort of alternating, going back and forth. Would someone like from group 2 like to share? Maybe, I know it's a long checklist with lots of questions, so maybe share something about this data set that maybe pleasantly surprised you, and then something that you definitely think should be a high priority for improvement.
Hi, can you hear me?
Yep.
Hi. So we both went through the files and had a discussion as we were filling the document. And long story short, we were pleasantly surprised by, the DOI, the references to the file, the references to preprint. So there's definitely somebody who went through the trouble of trying to make this at least as open source and discoverable as possible. The files were provided. On the other hand, the files were in Excel mostly, and it's not quite an open standard, and it's not readily read by machines because the way the data were entered into Excel files, there were like different tables, and you basically had to go through every single file and tab to get a full view of all the data that was used for the study. The data wasn't in tabular format. It's not machine readable as is. So I think that's stuff that they can do to improve. And just as an example, we opened one file and there were formulas, and in one of the cells there was an error in the formula that created, red condition. So by having a more standardized data set that's open source, that's not tied to Excel, and with the formulas surfaced maybe through a program or through a single source document, that would make this the data part of the submission better.
Awesome.
And then the one last thing, I don't know if it's a good entry point, is the language used. It was mentioned that there were qualitative descriptions, but there were no quantitative numbers behind them.
Gotcha. That makes sense. Great, thank you so much. All right, let's group 1. Do you have anything that you'd like to add to what group 2 said on either dimension?
I think overall I agree with them. I feel like the data was pretty well organized for the most part. I liked how they had the DOI, and then every mouse had a personal identifier with them. But I do again agree that Excel isn't necessarily the most open access. They could have just used a CSV file and maybe kind of merged a lot of these tables together instead of having different spreadsheets for almost everything. And I did like that they did include the formulas, that they were kind of transparent with how they were doing their calculations and analyzing the data for that.
Awesome. Sounds great. Yeah. So I think that perfectly encapsulates what we were shooting for with this data set. Also, I learned through the thanks to John that in fact that's a relatively new thing, that all mice have persistent identifiers. It's now becoming like a standard. But I don't have too much else to add on that dimension. So with that, we're actually going to now scale out even more. And I'll pass it over to Laura to talk about repositories.
Howdy, everybody. So by selecting a fair-aligned data repository, many processes of making your data fair are done for you. Repositories have different policies that can add value to your research data, guide you through metadata creation, provide a persistent identifier or DOI for your data, and support you with documentation guidance, citation support, and curation services. Next slide. Here's a list of organizations that can help guide you find the best repository for your data. Remember, you want to place your data where it will be best located for reuse. That may be a discipline repository, or it could be your local institutional repository. For example, Texas A&M University provides faculty, staff, and students access to the Texas Data Repository, and I put that link down at the bottom of this slide. Each repository has different requirements and limitations, as well as potential costs. These resources can help you determine the best repository to suit your needs. Next slide. So let's look at a repository example. Oh, I was going to do the slides, sorry. If you do want to go live, here's a link to the Harvard Dataverse. I'm going to share the screenshots so I don't have to tell John where to click. So here at the top, you can see that this repository has a user guide. They also have a tab for support. And on the right, they have a getting started portion. So next slide. Under that getting started section, you can see here they're telling you what size and what formats they accept in this repository. And on the left, they have options for researchers, or if you're depositing data for a journal, or if you're an organization wanting to make your data available. At the top, there's different tabs again, and let's look at curation services. I know this is kind of small, but when you click on the curation tab, here's their outline of the services they provide. There is some free consultations, but then they also have pricing for setting up your Dataverse and data sets for you for both Harvard affiliates and non-Harvard affiliates. Next slide. I'm going back to that getting started. Under the policies and governance tab, we here see the terms of use for how to use this data repository. And on the left-hand side, they also have a privacy policy and their preservation policy, which are things that you're going to want to check out, like if you can deposit sensitive data, and how long they're going to preserve your data, depending on what your needs might be. For example, if you're trying to meet grant funding requirements. Next slide. So you can also evaluate a repository by looking at the data deposits. I randomly pulled up a Dataverse here, and you can see in the blue area that there is a DOI and also a way to download a citation for this data. Below the little blue area are metadata fields and a license agreement. Towards the right, you can see how to access the data or contact the owner. And also note that this repository tracks downloads so that the data owner can see usage of their data. At the bottom are tabs where I can look at more detail at files, at the metadata, at the terms of use, or if this data has different versions. Next slide, please. So we are in the final stretch, and I appreciate everybody being so engaged. We are now going to spend about 15 minutes evaluating a repository. You will go back in your groups and you will be given a specific repository to evaluate using the questions listed on the Google document. Each group has a place where they can put their answers for each question. There are several questions, so you can either divide and conquer, or you can work together on each question. So group 1 will be doing Wormbase, and group 2 will be doing the global clinical research data. Are there any questions? And you can see each question and where you can put your answer per your group. All right.
I'm going to open the rooms. See you in a bit. It's back. Welcome back.
Great. Thanks, everybody. So let's talk with group 1. I know that sometimes it's difficult to find answers to these questions, just depending on the layout of their website and the repository structure itself. So any takeaways that you got, group one, about your repository that you examined?
I think the website seems a little bit outdated. I think I've maybe used updating. I think overall everything was pretty easy to find in terms of how to submit the data and how it'll be processed and things like that. But questions like how sustainable it is, there's really no mention of how long the data is going to be stored. But I think worm-based is pretty well known for people that use C. elegans, and it's really well funded, not only the worm-based, but also fly-based by the NIH. So I would assume that it would be running for a long time, long term. Visibility, I think, again, overall, it does have unique identifiers for all the data, which is good. You might have to try to learn exactly how different coding and things like that. And then for usability, it was well cited. It's clear how to download everything and how to cite using Wormbase. There's kind of like a FAQ of how to cite the database itself. And in terms of features, we couldn't really find how or what the file size would be. There wasn't really any description of that. But again, it's NIH funded. So I assume they would just take, especially for genome sizes, they tend to be a lot of gigabytes, especially for RNA, any genome, any type of data with that. The files are typically really large. So maybe that's why they don't have a limit to that. And then formats, they have GFF, which I assume is for just genomic annotations from what I saw, and then they have FASTA TXT or text formats, but that was mainly all I saw. And then licensing, they don't really have any clear licensing that I could see. And then finally, they do have the FAQ. It's mainly how to find specific data you're searching for, and then not necessarily any data, any information on how to navigate the site. So I feel like maybe that could be improved.
Okay. Great, thank you. Yeah, the data size is concerning because a lot of repositories do have data size limits. And so that would be something, if you can't find that information, I would personally ask the repository before you decide to select it to deposit your data, just so that you're not doing a lot of work for something that's not going to work out for your data. So good job. Group two, what were your findings? Anything interesting?
So basically, the Vivli, so the Vivli was quite reputable. It seems so. The site, it had a very good impression. Like it's nice and accurate and everything is findable. It isn't maintained. Both the site seems maintained. There are regular updates and so on. What we found was that this data repository, it provides some of the like additional tools that you can run actual codes on the like to verify the findings. You can not only submit the data, but also submit scripts, like how you process the data. So the users can like rerun them and see basically that you achieved the same results. And it has a subscription, so you can actually pay to get additional additional storage or prolong the data set, how long it will be stored and so on. It provides a DOI, it provides like a sponsor ID and an industry and organization outside links. So all seems, actually this is one of the better examples of data repository that I've seen, and well, with no surprise, because it has a subscription base, so you can pay for the service. So usually those tend to be much of a higher quality. And also it had a reviewer board. So probably there were people who are checking the spelling or something, so that maybe the keywords are spelled correctly, or use of a common dictionary. I don't know what that means, but probably means something good. So yeah, that's it.
Thank you. So that is something, since this one was a subscription, to think about when you're writing your grant proposals, that you might need to ask for some money for to pay for services for a data repository, either to host your data, or like they were saying that there was probably some curation there, and that a data expert went in and made sure everything was nice and clean and ran. And like we saw at the Harvard Dataverse example, that different levels of service cost money. So again, make sure you ask for that money in your grants so that you're not stuck paying out of pocket. So thank you, everybody. I appreciate all your hard work, and I hope this list is helpful for you if you need to go choose a data repository. And I'll turn it over to my colleague, Daniel.
All right. Well, we are almost ready to wrap up here. The only thing that we have left to do is some reflection. So here you've got some choices on how you want to respond to these questions. You can either respond just directly in the chat. You could maybe pick one of these questions, or we still have the Google Doc. If you scroll all the way down to the bottom, you can see these 3 questions here. And finally, you can also just unmute yourself and share what you're thinking about any or all of these 3 questions. I think that one thing to emphasize here is that the last 2 questions are not questions that hopefully you're asking when you're almost quote unquote done with your project, but it's something that you really try to think about as you're first starting to get your workflows going on your project, and something that you critically assess as you go along to see if things are changing or and things like that. Yeah, so we'll just give a couple minutes there to sort of either monitor the chat or the screen, or if anyone has anything that they'd like to say. Mm-hmm. Yeah, so all of these answers that are on the Google Doc look pretty well thought out and great to me. I would say feel free to download this Google Doc and think about these things actively, right? And we also just shared the sort of ML for chemistry checklist, which is pre-translatable over. And then we also shared the slide deck associated with the presentation today. So I think that that's all that we have for today. Are there any final words that need to be said? I think you will receive a survey, as was said at the beginning, but just in case you came in while that sort of announcement was playing, yeah, you'll receive another survey to sort of assess how useful this workshop was for you.
I'll go ahead and put that information up if you all are completely finished.
Yep, I think that we're all done.
Yep.
All right.
I'll stop sharing.
Oh, there we are. Well, I want to thank our speakers for today and thank you all for participating. As a reminder, our next session is going to be Wednesday, May 11th, where we will discuss data privacy and policy. We hope to see you there. Thank you again. Bye.